Now, our topic today is applications of light wave. In particular, we are going to deal with optical instrument. When we say optical instrument, we mean all those instruments that we use that they make use of light, and we don't know this application of what we have done in the past. Don't forget, we have done something on the lens, how image form on the lens. Let's start from the use of projector. Look at projector. It has lens like that of converging lens we have done in the past. So it has this type of part. So there must be a source of light here. We have source of light. Then there will be something here that will prevent it from that light. So we call it what? Condenser. So after condenser, we are going to have a slide carrier. We have slide carrier like this. So after that, now have convergent lens. So the purpose of this one, don't forget we have done convergent lens before. If you have an object here, look at it. The reason why our object must be upside down, that is inverted object, is that when you place object in front of convergent lens, except if that object is between F and C. Now our object will not be between F and C, and if object is upright, that is erect object, it will form inverted object image. In order to avoid that, we now make our object to be what? Upside down, so that at the end of the day, the image that will form on the screen will be what? Upright. Now, as you can see from the diagram, look at the diagram. See that we have lens. Then the image of the object from the slide carrier will appear upright on the screen. So another instrument that we normally use, another device, is that of a camera. The same thing applicable to the camera. For the camera, so camera also has a lens and it has what? Screen. So this lens will magnify the object, the image of object. Then it will appear on the what? On the film. We have as the picture that we are going to take from the film. As you can see, look at the picture of the camera. So it applies, it's an application of what? Of the light wave, that is optical instrument. Then the next one is a simple microscope. We have microscope, we have telescope. For microscope, we use it to view a very small object that's very close to the lens, to make it what? Magnify. Then opposite of that of a microscope is that of telescope. For telescope, we use it to view a very big object but very far distance, at a very far distance from the lens. Now let's talk about microscope first. Microscope, they have two types. We have simple microscope and have compact microscope. For the simple microscope, it comprises of only one lens, and it's part of what we have done in the past. What we just need to do, by the time you place your object, don't forget we have done lens before. We have this for the lens. So we have F and we have 2F. Then this place is what? Center of the mirror. We have F, we have 2F. Don't forget, if you place your object between F and C, you are going to have virtual image here. Virtual image. So in that case, placing object between F and C, it means you have made a simple microscope. You have made, and it's also called magnified glass. So as you can see, look at the diagram. Look at where the object is. Object is between F and C, and look at image. Then the second type of the microscope is that of compact microscope. For the compact microscope, it comprises of two lenses. It comprises of two lenses. So as you can see from the diagram, so you can see it. The first one is very close to the object. The one that's very close to the object is called objective lens, while the one that's very close to the eyes of the viewer is called eyepiece. What will happen is the objective lens will form inverted image. As you can see from the diagram, we form inverted image. That image will now serve as object for the eyepiece. Then eyepiece will now magnify it again. As you can see the final image. So that is how compact microscope works. Another thing you still need to know about compact microscope is how to find the magnification power. Magnification power of the compact microscope, what you just need to do, you find the magnification of the first lens, you find the second one, you multiply the two together. Don't forget it comprises of two lenses. Therefore, magnification power of compact microscope is equal to magnification of the first lens multiplied by magnification of the second lens. And don't forget, though it comprises of two lenses, both of them they have short focal length, right? But the focal length of the lens very close to the eyes is longer than that of one that close to the object that we call objective lens. Therefore, the focal length of eyepiece is longer than the focal length of objective lens. Now let's move to the telescope. For the telescope, telescope is a device that we use to view an object very far distance, but it's very big. A very big object, but very far distance. Now we have different type of telescope. So we have astronomical telescope, we have Galilean telescope, even we have a terrestrial telescope. We have prism binocular as well. Now, how does telescope work? We have an object, your telescope like this. You are going to have two lenses. This one is, let's say the eye should be here. Therefore, this one that is facing object at a very far distance called objective lens. I will add it in case of a compact microscope. Then this one will form image. It will form inverted image here, and that inverted image will serve as object for this one, and this one is called eyepiece. Now we have another way you can arrange this one, the two lenses, such that their focal length will coincide. And don't forget, this one is facing object at a far distance, at infinity, so automatically the image will form at F. So the image, this one will form image at F. So if you now want to arrange this one to form normal adjustment, it means you adjust this one so that its own focal length also will be here. So this image that form here at principal focus of this, so it's serving as object for this. If principal focus of this one also is here, it means the final image also will go and form at infinity. And that kind of arrangement is called normal adjustment. Then for the telescope, if you are looking for magnification power of the telescope is equal to the focal length of objective length divided by focal length of the eyepiece. So you find the ratio of the two, whatever you get is magnification power of the telescope. So for the astronomical telescope, it comprises of two converging lenses. As you can see, look at it on the screen. So it comprises of two lenses. Then we have Galilean telescope. So the Galilean telescope that contain one converging lens, one diverging lens. As you can see, look at it. So you can see the final image. Then we have terrestrial telescope as well. That one comprises of three converging lenses. As you can see it on the screen, it has three converging lenses. It's only Galilean telescope that combine the two type of lenses together. We have converging and diverging. Then we have prism binocular. Prism binocular comprises of four lenses and four right angle triangular prism, as you can see from the screen. Now, so that's that about applications of optical instruments. So the next topic will be on the use of eyes, and we are going to compare eyes with what? This lens. So therefore, eyes also is referred to as what? Optical instrument. Please don't forget to like, share, and subscribe. Then on every weekend we are having class where we are going to enjoy physics, chemistry with an expert. Another person in chemistry, another person in mathematics, as well as English. You are welcome.